Alright, sketching slope fields. Alright, let's get started here. What is a slope field? A slope field represents a differential equation on the xy plane. It shows the slope of all the particular solutions to that differential equation. So it's the slope, the graph of the slope for all the solutions, for that family of solutions that it was saying last time. It has a family of solutions. So here's an example. dy dx is equal to 2x. So dy dx is 2x, is linear, no? It's a line. And it was the derivative of what? Of some quadratic, no? And when we had some like y, say it was y equals x squared, we took the derivative. Well, look, y equals the x squared, the derivative of this, y prime is going to be 2x, but we lost the constant. So that's why we lost this constant. So it could have been anything, no? It could have been any quadratic going like this or like this or like this, because we lost the y-intercept. And that's why it's a family of those. So here, dy dx equals 2x. What are the graphs of them? Of the slopes, of the derivatives, no? Well, it's already, dy dx is already, it's a derivative. It's a slope field. You don't necessarily have to be doing this table that I'm having right here, this little weird little thing here on this thing. But it helps in graphing. Let's say that x is those numbers, and we're going to graph x is -2. Well, this represents the graph right here. And then the y is going to go from -2 to 2. So we're going to get these numbers. That will be the slopes at those particular points. All right, let's copy this down, and then I can do an example, and then you guys can come up and do one yourself. Yeah, it's pretty straightforward. It's just that it's very repetitive, and it's a lot of calculating real quick. Say that this is, well, I don't know, this is dy dx, the graph of dy dx. Is it? Would it be correct to say that? Oh man. Look, what's going on here is this. Well, this is still x, and this is y. This is x and y. So. So what we do is we plug in x and y. Sometimes we do have x and y's here on the right side, but yeah. So let me get dy dx is the number that's going to come out right here. Watch. So if I plug in x is -2, well, it's dependent only on x. So if I plug in, there's no y to plug in here, so it doesn't even matter about the y. So x is -2. If I plug in x is -2, what's 2 times -2? -4. So meaning that at -2, x is -2, y is -2. At x is -2, y is -2. The slope is what? The slope is what? So it's going to be down 1, 2, 3, 1, 2, 3, 4 over 1. So the slope is like this. So we're not going to do the whole thing. We're just going to say at -2, the slope is. We do like a little dash line like that, meaning that the slope at that point is about that. So basically, it's not depending on y. So what is the slope going to be here again? No, hold on here. Yeah, so I'm saying that this is -4. What's the slope here? It's still -4. Oh yeah, it is -4. And what's the slope here? So it's going to be whatever. Maybe it should be more steeper. That's all. There's all there's to this. So it's not depending when there's no y here. It will be the same along the y. Going up and down, vertical. Okay, so what's the slope at negative 2? Negative 1. Negative 2, and it's going to be negative 2 here, which at negative x is negative 1 will be negative 2, which is less, not as steep down, but more like, maybe, I don't know, down 1 over 2, down 2 over 1. That's the idea of this, doing this, like, less steeper. It makes sense though. You'll see that it's going to do a U and everywhere, no? So at 0, what is that 0? 0. 0, 0, 0, 0, 0, negative 2, negative 2, negative 2, negative 2. So here's 0, the slope is 0, slope is 0, everywhere is 0. Slope at 1? So 2, so it's going to be the opposite going like this. At 2 is what? 4. So it makes sense what it is. And if it says like what is the particular solution, say the particular solution at 0, 0, say 0, 0, well, it would be what? It would just be, it would be y plus x squared, no? So at 0, 0, it will be, makes sense, no? And then it's all of them, no? And then if we lost the constant, so we'll be talking about this one, it's talking about this one. That's kind of what this is. If we wanted to, we don't have to do this. Right here, what I'm gonna do is say we, because we already done it, no? Before, if we actually wanted to find what would be it would be move that dx over to the other side. We don't have to do it, but let's just practice some anyways. dy, then this will be 2x dx. Then we integrate. Then we do y equals what? Like I said, there's no plus c. Who cares? It's just the integral of dy is just y. Integral of this is what? X squared plus c. And that's the family of whatever that c is. Makes sense, no? Because we lost it. And so whatever that c is just up and down. Move it up and down. It's all that's the family of them. So let's go ahead and do this one. Yeah, let's go. Well, I don't know. Let's just do it. What would it be then? It's not dependent on the x, so it's going to be the same along the horizontal, no? How can we remember this? How do see? I remember it's not dependent on the x. It's not dependent on the x. So it's the same along the x? Is that correct to say it? The same slope along the x? How can we remember what it's going to be? Look. So we're going to do this table. And we're just looking at on this picture, no? So what's the slope at negative 2, negative 2? Oh, I did the top one. So if I did the top one, hold on here. If I do the top one, 2 times 2 is 4. Across is going to be the same, no? Because it's not dependent on x, because it's just dependent on the y. So going across is going to be the same. But so at 1 is going to be what? 2, then 0. So going across is going to be this. So then it's going to be 2 across, 0 across, negative 2 across, negative 4 across. So when you plot those, so the slope at 2 negative x, no, at negative 2, 2, I guess I'm starting here at the top, negative 2, positive 2, the slope is 4, meaning it's going to be like that, and all the way across. Then a little less steep, then negative slopes. And what is this now? Let's see. Can we figure out what the actual solve it? No, solve for the family or whatever it says. So it's going to be what? dy equals 2y. No. See how we're gonna solve this. So we gotta move the y over with this dy, no? And move the dx over to the other side, no? So this is gonna be what? dy, look, let's go. dy over dx is equal to 2y. Now you're gonna say you move the whole thing or you just move the y? Just move the whole thing, no? They just divide by 2y. Divided by 2y, cancels out. Divided by 2y, and then dx, move it over there, no? Dx, move it over there, dx. So it's gonna be, so dy over 2y, then dx. That's just a constant. You could just move it out, 1/2 dy over y. And what's the integral of this left? So yeah, it's going to be 1/2. 1/2 what? ln absolute value of y equals what? Is x plus c. Yeah, the integral dx is x plus c. And then you could just, we're going to do that later. More of this. We'll focus on that. But in any case, it would be some kind of. You always want to finish it or no? Well, if we finish it, look, you times this by 2 because we want to get the y by itself, no? Times it by 2. Get this. So this cancels out. So put it here 2. So this is going to be ln absolute value of y equals 2x. If you distribute this, will be 2x times 2 times c is another constant. Is that okay? You multiply a constant by time it makes another constant. So who cares? 2 for that one, whatever. Then here's where the pre-calculus starts again, where you're like, oh, here we go with pre-calc. How do you solve for y? Put it in exponential form. So if this is ln, it has the basis e to this power is equal to y. So y is going to equal to, and now the question for you might be, why does the absolute's going to go away? That's a good question. Like somebody asked me. So you're like, why isn't it? Why equals that? You know what? Like on the AP, they just kind of like forget about the absolute after once they solved it like this. There's a reason why exponentials go like this. In any case, I might answer this question later on. But the absolutes drop off, so it's y equals this. Then that's enough. Y equals that would be it. And then there's another properties of exponents as to what the next answer is. The actual answer is c times e to the 2x. Why? Because then this becomes a constant as well. Anyways, we're gonna do that in the next section, and we'll focus more on it. And what we're focused on right now is the graphing of it here. Let's go. Okay, now let's go to number 1. This is the kind of problem will be on the AP test, probably. Let's go. Let's copy this one down. Sketch the slope field for the differential equation there, and find the particular solution of that goes through 0, 1. So if there's no y, what are we going to say? What are we going to say if there's no y? It's the same along the y, yes? Does that make sense? That's the way I'm thinking. If there's no y, it will be the same along the y, no? If there's no x, it will be the same along the. It's not depending on the x, so if there's no x, it will be the same along the x. I'm just trying to figure out a way to just remember this stuff. In any case, does this one have both x and y? It has both x and y. Okay. So we're just focused in the middle again, right here. Right here, we're focused to see what's going on there. Let me see that. Okay. Quickly, let's go here. What's the answer to x is negative 2, y is 2? Go. X is negative 2, y is 2. Go to write that answer. What's the y prime? What's y prime for x is negative 2, y is 2? The top left, top corner.
I was trying to find for y, right?
Give me the slope at x equals negative 2, y equals 2.
Wait, this one, right?
That's negative 2, 2.
Okay. Wait, negative 2, 2? So.
This is the top left.
Okay, so
yeah, right there.
Okay. 2, 2. Just. You just plug it in.
This is, yeah, it's
plug
not
it
that
in.
hard. What are you doing?
Sorry, I'm just overcomplicating. Sorry.
Hey, somebody tell them what to do. You guys don't know what to do? What? Tell them what to do.
You just plug in the numbers?
Yeah.
Just plug in, you don't have to write it down.
So
You do it in your head.
Yeah.
You do everything in your head. Why can't you? Look.
Write the answer in the box.
X is what? X is what?
negative 2.
Y is what?
2.
So what's negative 2 plus 2?
0.
Put 0 there.
Oh, so.
What do you,
What's the thing?
what you do,
oh,
man?
My bad.
Oh, yes. Yes. Yes.
I'm just overcomplicating.
Yeah, you do.
That's like.
Anthony, let's go. X is 1, y is 2. X is 1, y is 2. No. Just listen to what I'm saying. X is 1, y is 2.
X is 1.
X is 1, y is 2.
This one, right?
Yeah.
Okay. Is it?
You guys don't know how to do basic math or what?
No, the way you're saying it.
What do you mean the way I'm saying it?
I don't know. I think you're confused.
What the heck? Is it weird what I'm saying? No. You're this is what the derivative or the slope field is depends on this x plus y thing. Whatever that x plus, if it's something else, you just plug in the x and the y in there. And that's going to give you the derivative or the slope at that point. Crystal, let's go. Um, 0, 0, Crystal. Choose one. Choose one. Choose one.
This one.
All right. So you get it now? You guys get it now? So basically, like I'm just saying, I do this table so you'll know where you're at and how to do it. In reality, you should be able to do it in your head. So we're gonna go with, let's go at 0, 0, 0 plus 0, 0. The slope now. Slope of 0 is what? Oh, now you're like you're making it more complicated. X is is 0, y is 1, 0, 1, slope is 1, you get, yes, yes. X, well, x is 0, y is negative 1. Huh? X is the negative 1, y 0. Is it going down? Negative 2, x is, what is negative 2? Is it going to get steeper and like go like this more? Like that? It's good. 0, 1. And then gets steeper and steeper and whatever. Because you know what slope is? Slope is rise up 2 over 1. Like, so when you take the AP test, say go like that, no? Say you got that, and that's what it is. They give you a slope field. They say that they already gave you a slope field. Then they say, this is, it better not be getting a 0 at 100 and, how many is that? 108 points? You better get this one. They're going to have one like this. They give you the slope field, and they go, what would be the particular solution that goes through 0, 1? X is 0, y is 1. X is 0, y is 1. Man, this thing is going like this, and then it seems to be going like this. I probably mess it up too, but it just got to follow this pattern. It's going something like that. Is it just going like that? I don't know. Which I already had. But they're gonna know. They themselves probably can't even get it right. See, I messed it up already. Look, I got it wrong. I wouldn't. You better not be doing this. Did I get it right? Not even close. It's right here. 0, 1, 0, 1 for sure here. And here's where you gotta just be able to see the field. Like water, you know, rush everywhere. You gotta see how it goes. Let's go. Number 2. Continue on. Let's continue number 2. Write it down. Let's go. Sketch. Sketch the slope field for the differential equation. It's going to be the same along the what?
X.
The same along the x, no? If you really understand that, then you don't need to be doing this table stuff. Maybe we can just do 0. And then along the y, there's 0 up and down. Top one. Oh, right there of 0. Top one of 0.
For this one, right?
Mm-hmm. Negative what?
403.
Oh, it's for negative 403?
Yeah.
Okay.
Erase it.
Yeah, well, write it now better.
Yeah, sure.
No, you could have just, yeah. All right. That looks like a 9, right?
I just write it like that, sorry.
All right. You guys get it, no? So we can move on. So you're just plugging it in, and I said here it is negative 403. So this is gonna be what? Why is this a little messed up? I need to redo my let's go with this, let's go with this, let's go with this, let's go with this, let's go with this. This is gonna be what? What? I said y negative 1/3?
Yeah.
So what? So we're gonna do what? Negative. So go down 4/3. So what's the slope means the 1, 2, 3, 1, 2, 3, 4 over 1, 2, 3. So it's gonna be some slope going like that. So at 0, 2, 0, 2 is going something like that. It's more like that. Then 1/3. 0. Then what? Negative 1/3. What? Negative 1/3? That's not. Something like that. And then negative 4 down over 3, more like that one. And then what did I say? It was the same. We're saying that it's the same along the what? So better be doing this right now like this. And then do this like over here like this. And then do this here. And then do this here. And then do this here. Like that. That's kind of like what we're doing. Well, then we could just keep doing this so you can get the whole thing here. And then do this more like this, more like that. And then these one go like this. Yeah. Oh, like that. And then this one go like that. Something like that. Okay. And then sketch the slope field. Then sketch the particular solution that passes through the given point. 0, -3. 0, -3. Right here. So let's do this slope field here. Blah, blah, blah. Man, this thing is going like this. Is it? I hope so. All right. Let's see how close are we to it. So, well, it's just asking for 0, -3. It's asking about this one. You don't have to have that one. But it would be the, I guess it's a rational, no? You don't have to do that other one over there. It's this one. Why would you do the other one? Like, it's asking for 0, -3, not the other one over there. All right. Okay, look. I already have the homework, and here's the homework. That's the one that's on the homework. Let me give you the homework. It's in the back of this worksheet here. This one. Let's take a look at the back. I think, is it in the back? Is the first one?
Yeah.
All right. Take a look at it. Which one would be most likely associated with this slope field? Is it the same along the Y? Is it the same along the Y?
Yeah.
So if it's the same along the Y, what did we say? If
There's
it's,
no X. Right?
it's not dependent on X?
Yeah, there should be no X.
There should be no X?
If there's no X. No, Y, sorry. No, if there is no Y, it's the same.
There's no, see, hey, get it straight, man. Get it straight.
My bad.
What is it? Look, is it the same along the Y? Is it the graph?
Yes.
If it's the same along the Y, what?
There is no Y. Right?
I'm asking what?
Yes.
Is it there's no Y? Is that the way we're going to remember it? If it's the same along the y, there's no y.
Yeah.
So we can remember this. If it's the same along the y, there's no y in. You know what we mean, no, in the on the what is dependent on. If it's the same along the y, there's no y. Oof. There's no y? Well, doesn't that give it away?
Yeah.
All right, let's do problem 1. The slope field for a certain differential equation is shown. Which of the following could be a solution to the differential equation with the initial condition y of 0 equals 0, y of 0 equal to 0, right here. Oh, no, not there. Where? Right here? Yes? So this thing is going something like that. It has a what? What does it have here? What does it have here that there's nothing here? It would be, does it have vertical asymptote that dy dx doesn't exist? This is a vertical asymptote at -2. What does that mean? What does that mean? Okay, but this is the slope field. No. This is already the equation of it. Anybody can tell me what the heck is going on here? Which one would it be? Which one cannot be?
Can't be. I don't think it's B.
It can't be what?
B to the X.
It can't be B? Why can it not be B?
Because
Well, look. This is not dy dx. Dy dx is that. This is actually, they're saying that these are solutions. What would be the antiderivative to this graph? And the antiderivative is the solution, the particular solution. These are particular solutions. How can we figure out which one of them would be a particular solution? Well, look. It really can't. It can't be this, no, because it's defined everywhere, and there's nothing wrong with e to the x. E to the x is everything's good, and then if we plug in x is 2 here, see, if we plug in x is 2, there's no problem here at 2. See, there's no problem here at 2. But then if I do plug in 2 here, that'll give me 2 squared is 4 minus 4 is 0, which you should have some problem. Maybe one of these ones here, because now this one is that it has some vertical asymptote. Look, if I plug in x is -2, what do we get?
0.
At the bottom, which is an asymptote, no? That's why this is an asymptote here. So which one out of these two?
Wait, why do you not put a -2 for A?
What, say that again?
Why don't you put a -2 for A? Like the x squared?
That's what, yeah, you plug in
put
-2.
2.
Oh,
But either way,
Either-
there should be, for that top one, the
you should.
2 positive would be a pretty much.
No, if you plug in x is 2 here, if you do plug in 2,
Oh, there'll be another one. Okay.
So between these two, what? Which one? Is it the same along the? See, there's no y, so it is the same along the y, no? So what can we do? Why don't we just test the point? Test the point. Let's test the point. What? 0, 0. It should give you what? Slope. But this is not the dydx to test it like that. But which one is it? C or D? Why? Why is it C or D? Anybody? It's gonna be C or D. What do you know about tangents? What do you know about tangents?
It has a lot of.
Oh, it goes something like that, no? And it has a lot of asymptotes, doesn't it? It's good, huh? Anthony, you get it? It makes sense or what?
I did.
Kind of, this is a lot of, the thing about this is that you have to have such a strong pre-calculus. When I say, hey, what's the tangent function look like? If you have no idea what it looks like, then you're running wrong. You know what the tangent function looks like, Anthony? What you guys learn in pre-calc? Let's go to number 2. We're almost done. This will be it. Or am I going to just give you, we're done. You guys just figure it out and then I'll show you this one. I'm done with the